An effective fleet management dashboard is a key tool in any logistics team's arsenal. What we want is a clear, up-to-date snapshot of all of the vehicles in our distribution network. Hi, I'm Kevin from Budibase, and today we're exploring how to build professional dashboards using existing data. As we'll see, Budibase is ideal for extracting insights from all kinds of data sources, allowing us to make better informed decisions. Let's have a look at what we're building. A fleet management dashboard is a reporting UI that displays key metrics and KPIs that allow us to know how we're doing as a company. These can include things like where our assets are, how much we're spending on fuel, our performance in terms of deliveries, statistics around our overall vehicle utilization and driver safety, or any other relevant data that decision makers might need. Of course, this will vary greatly depending on the size of your operation and what you're doing day to day. As you make these dashboards your own, you'll add and remove cards or charts that allow you to make decisions inside of your organization. But once these dashboards are built, they query live information, allowing this to be a great launching pad to make decisions, as it's an up-to-date and visual snapshot of how you're doing as a company. Let's dive in and build this together. If you haven't already, you can sign up for a free Budibase account to follow along with this tutorial. Once you've done that and logged in, you'll arrive at this app portal where you'll have all of the apps you've created, or none if you're just logged in, and we'll create a new app. I can create a new app from a template, I can import an app, or I can start from scratch like I'm going to do today. I'll be asked about the URL I want to give my app. I'm going to call my app Fleet Management, and my URL will be updated to reflect that. I'll click on Create App, and I'll be brought first of all into a screen where I'm invited to add a data source. Budibase, we want to help people turn their data into action, so integrating data is going to be the first thing we'll do. If you don't have data, you can add tables of your own using Budibase's internal database. You can connect to a series of REST endpoints, relational or non-relational databases, or even spreadsheet applications like Airtable and Google Sheets. I'm going to use PostgreSQL because that's where my data already exists. I'll need to provide my details, my host string, the name of my database, my username, and my password. I'll enable SSL and I'll click Connect. When I do that, I'll be offered the opportunity to select which tables from the database I want to import. I have two tables that are relevant, deliveries and vehicles, so I'll select both of those and fetch them. We now have access to this SQL data in a spreadsheet-like environment where we've got full CRUD functionality. We can create new records, we can read and update existing ones, and we can also delete by clicking and pressing the bin. Once we've got the data, we can start manipulating it in any way. We can add new tables, which will be represented in our database, and we can add custom queries, which we're going to make a lot of use of as we build our dashboard. There's a little bit of housekeeping, which is helpful to do. Going to go into our vehicles table, and we can see the first column, mileage, is what's being used as the display column, which isn't very useful. I want to use the registration as the display column, so I'll go to the three dots, and I'll click on Use as Display Column. Also the status, at the moment this is strings. What I'm going to do is I'm going to use this three dots and change this into an options list where I can put on delivery, idle, and in maintenance. The benefit of that is we get this tab-like representation, and we also then get a drop down as we add and update these records, making it easier to manage than strings. Budibase will automatically assign colors, but in the edit column, we can set custom colors if we prefer. We'll make similar changes in our deliveries table. We'll let the ID be the display column here, and we'll change the origin and destination to be options lists. We've got Seattle, Boston, Pittsburgh, and Salt Lake City, and Reno. We got them all, and a similar list for our origins. So now we've sorted out our data, we can start building our dashboard. Each of our reports is effectively made up of 4 components, and we'll take each of those in turn. First of all, we will go to our design tab. I'll create a blank screen, and we'll leave this blank because we're going to have this as our root. We have our role-based access control. So basic means we're expecting our users to log in. Public would mean they don't log in, and power and admin are both elevated roles which allow us to segment our application. I'll leave it at basic and click done. The first component we want to add is a container. And this is where we're going to place our 4 cards block. So I'll name it cards container and I'll add a cards block inside there. What a cards block does is it accepts a data property and iterates over that data property, displaying a card for each row. So in this instance, I have 8 cards representing the first 8 deliveries. If I want to, I can increase the limit, so I can show 9 or 10 cards. And if there are more than the limit, I can enable pagination. I want to create a query that is going to give me some data, but there's actually only going to be one metric that I'm going to pull out of that. So we'll end up only having 1 card in this card block. So if we look at our finished dashboard, we can see there are 4 cards: the average age of the card, the average vehicle mileage, the current vehicle utilization, and the fuel spend this month. So we're going to get the first 3 from a single query. So let's go and do that now. Go back to our data tab. We'll click on PostgreSQL queries and we'll create a new query. While I'll create this query now, know that all of the queries that we develop in this application will be available in the accompanying blog post. So I'm going to create a select statement and return 3 things from it. The average of the current date minus each vehicle's registration date. So I want to cast the average of the year, which I'm going to extract from age between now and the registration date. Add on the month. So extract from age of now and the registration date. And I'll divide that by 12.0. I'm casting that as a decimal and I want it as the average age. Then I want the average of the mileage attribute. So average mileage. And I want to call that average mileage. And lastly, I want the count of the vehicles where the status attribute on delivery divided by the count of all the vehicles. That'll give me a decimal. So I'm going to times that by 100 to get the percentage. So count up the case when the status equals on delivery. That's going to be 1 and end. Turn it into a decimal and divide that by the count of all of them altogether. Again, that's a decimal, so I'll times it by 100 and I'll call it percentage on delivery. So there are the 3 bits of information I want. Where do I want them from? I want them from the vehicles table. So I'll click on Run Query, and that will get me my information back from the database. The average age and the percentage on delivery are pretty horrible decimals, so I'm just going to wrap them in a round statement. 2 decimal places for that one, and round to 2 decimal places in that one. Let's rerun. That's much tidier. What I get here is a summary of the first record, if there are more than 1 record that comes back as a result of this query. The schema will allow me to be able to set this percentage on delivery. It's actually a number. I can change that if I would like so that it may be represented differently on the front end. And the preview will show me all the rows that are represented by my returned query. There only is 1 row for this, but we're fine. I'm going to name my query average vehicle stats and save it. Now back in the design tab, I've got my card block and I'm going to switch over the data to be my average vehicle stats. There's 1 card because there's 1 return row. Now each card, it has a title, subtitle and description, which we can have as a fixed value as they are at the moment, or we could use the lightning bolt, which allows us to bind some dynamic data. So from our cards block, we're going to start off with the average age for the title, and their subtitle, we'll call it average age. I'm going to duplicate that. And the next one's title, I'm going to set to be the average mileage. I'll duplicate that. And for this one, I'm going to set the title to be percentage on delivery. Put a percentage sign at the end of that. I'll say vehicle utilization. These are inside a container, so I can click on the container and change the direction to be horizontal and click on wrap. So as the screen gets smaller, they'll stack, maybe center them horizontally. And as the screen gets bigger, they'll spread out to take up more of the space. I'm going to add a fourth card. For a fourth card, we want to calculate how much money we've spent on fuel so far this month. To get this, we're going to need a different query, and so we'll go and do that now. So data, Postgres, queries, create new query, and this is going to be our total fuel spend this month. So what we'll do is we will select, we're going to get the month and the year and the fuel costs, and we'll group by month and year. So what that will do is SQL will group together all the records that match a month and year and add together the fuel costs. So I'm going to get the month first of all. So I'll get cast extract month from the departure date, and that's going to be as an integer. And I want to refer to that as the departure month. Equally, I want to get the year. So extract year from departure date time as an integer as departure year. Then I want to sum up the fuel costs as total fuel cost. The table I want to do that from is my deliveries table. And what I want to do is group it by, which means that our sum is not just going to be the overall, it's going to be by these groups. I want to group it by the departure year and then the departure month. And then just so it's in order, if I want to display it in other ways, I want to order it by departure year and departure month. I run the query. I get first row's representation. So departure month 9, departure year 2023, total fuel cost 396. This schema allows me to see that Budibase has inferred that they're all numbers. And the preview shows me that there are two values so far. So this is a pretty early stage dashboard. There's not a lot of data here, but there's enough data for two months, 9 of 2023 and 10 of 2023. So now I have my query, I'll save it. And I'll go back to my design tab and duplicate my card block one more time. But this time I'm going to change the data to be my total fuel spend. 2 cards here because there's 2 months and ultimately there might be more than 2 months. So I'm going to add a filter. So I'll add a filter so the departure month equals a binding to the current month. And to get the current numeric month, I'll use JavaScript. I'll create a variable for now to be new date. And then I'll return now.getMonth. And that's 0 indexed, so I'll add on 1 to get it to be what we want it to be. And then for the departure year, I wanted to match a binding again to a JavaScript function. So I'll get current date and time, and I'll return now.getFullYear. And what that should do is it should return 1 card because there's only 1 card that matches our date and year. And so then we'll go to our title and we'll change our title to be our card block, total fuel cost, and we'll save. Maybe put a dollar or a pound sign depending on your currency in front of that. And we'll call it total fuel cost this month. So next we want a pie chart that breaks down how our fleet is spread out on the ground. We want this chart to occupy half the screen because we're going to put another one beside it. So we'll start by adding another container. And we're going to need to create another query that's going to count our vehicles by location. So we'll go here, we'll add a new query, and this is our vehicle count by location. We'll select d.destination. We're going to do a join here, so that's why we're using d, current location, and count star as vehicle count, just how many is in the row. We're going to do that from our deliveries table, which we'll call d, deliveries table, which we'll call d. I want an inner join, because we need to see where they are. So we'll select vehicle and the max of the arrival date time as the max arrival date. And we'll select that from our deliveries and we'll group it by vehicle. So what we're saying is, where are they now? They may have multiple records where they've said they've arrived, but we want the latest one. That's what this max arrival date time is saying. And we're getting the vehicle there. And we'll call that subquery recent arrival. and we're joining it on d.vehicle and our recent arrival.vehicle. Both of them have that vehicle, and we want to match it on them. And we want to match the date time. So arrival date time equals recent arrival date. Finally, we'll group it by the destination. So group by destination, which was in our first table. So if we run that query, we get the first one back. We've got one vehicle in Pittsburgh. Our schema shows us that there's a location, which is text, and a vehicle count, which is actually numbers. I'll just change that to number. And our preview then is showing our 4 locations that have vehicles in them and how many are there. So we'll save that query. We'll go back to our design tab, and then we'll add a chart block inside of our container that we created already. So we'll add a chart block. This is going to be our vehicle location. It's going to be a pie chart. The data we're going to use is our vehicle count by location. Our label column we'll use for current location, and our data column we'll use for vehicle count. And there we have this nice pie chart. Probably don't need that legend because of the on hover, but yeah, that looks good. And lastly, we want to make some space for the other chart. So we're going to add some custom CSS to our chart. We'll set the width to 50% and we'll fix the height at 400 pixels. And save that. Okay, so next we're going to have a bar chart that we want to display our vehicle's average fuel per mile. So we'll create a query. So data, queries, create new query. This is going to be our fuel cost by vehicle. We're going to select the vehicle and then the average of the fuel cost divided by miles as the average cost per mile. From which table? The deliveries table, grouping by what, grouping by vehicle. So we run that query, we'll get the first result back again. The average cost is a horrible decimal, but we're going to graph this, so we don't need to display it. Otherwise, we could introduce a round statement into our query to tidy this up. But for now, we've got this, that looks good. Our schema says that's a number, which is fine. Then our preview looks pretty good. So to save that, back to our design tab, and we'll add another chart block inside of our container. This chart block is going to be our fuel cost. Our chart type is going to be a bar chart. The data we want to use is our fuel cost by vehicle. We will set the label column to be vehicle, the data column to be average cost per mile, and we'll select it to be horizontal, so it sort of does that horizontally as well. We'll add some custom CSS to let width be 50% and save that. And lastly, we'll get our container to orient horizontally, so those charts are displayed side by side. Awesome. One more chart to be able to finish off this page. So we'll add another chart block. This wants to be on its own further down. And this is going to be our daily fuel costs. We want our daily spend. We don't necessarily have values for every date, so we'll need a query to take that into account. So we'll go to our data and add another query. Queries, create a new query. And this is going to be our daily fuel. So because we won't always have values, we're going to use a left join to make sure that we have a row for every date. So I'll create a query that's just going to give me a whole load of dates. So with all dates as, I want to generate, so select, I'll call these generate a series. And I want to generate it from date of this month, so trunk month of the current date, and that's going to be cast as a date. The current date, which I'll make sure is cast as a date. I want the interval to be 1 day, cast as an interval, and the final result of that I want to cast as a date. So what this is going to do is it's going to generate a table which just has a current date where they're separated by 1 day, so one for every day. I'm going to select ad.date as departure date. I'm going to coalesce the sum of d dot fuel cost and 0. So if there isn't a fuel cost, don't add them up, just give it a 0. And I want that to be total fuel cost. Where do I want to get that from? I want to get it from my all dates, which we have up above. Create it here. But we still haven't got this d date, and that's because we're going to do a join. So I'll do a left join of deliveries, which I'll call D. What I want to join on, I want to join on the date of D dot departure date time with the AD dot date. Now, because we're using an aggregator, we'll need to group, so we want to group by date, so AD dot date. And just to tidy it up, we'll order it by date as well. We'll order by AD dot date. So we'll run that. We get 23rd, 1001, tool cost is 95. Our schema says date is text. We could set it to date time, and fuel is there. And our preview here, we can see all dates of this current month, 1 through 20, and anything where we don't have a value, our coalesce function is making sure we're putting a 0 in for that as well. So we'll save that, and now we can create a line graph for that. Final chart block at the bottom here wants to be a line. I want to use our daily fuel costs. We're going to let the label be the departure date and the data be the total fuel cost. So we can see that has given us a pretty decent view of what's going on. Now, yours might look quite bright. I've got this set to dark. So if you go to screen and theme, I've got mine set to Nord. By default, yours might look a bit brighter like that, but if you want to, that's where you would change it to be dark. Next, we want to build a very similar dashboard page for our deliveries data. So we'll start by clicking on our screen up here, 3 dots, and duplicate it. And this time we'll call it deliveries. Like our fuel, we'll care about getting some summary cards. We'll want some data for these charts, but we want it relevant to this new context. So we're going to create some queries. So I'll go to my data, Postgres, queries, create new query, and I'll paste in the query I'm going to use here. What this is doing is it's getting the current numerical month, the current numerical year. It's counting the number of rows that match that criteria that we're going to give. It's counting the rows where the elapsed time exceeds the time limit, both as a number and as a percentage. And then finally, it's finding the average difference between the time limit and the elapsed time. So remember, all of these queries are in the attached blog post. If I run that query, you can see I've got everything I was asking for. This percentage late and average time distance, I want those both to be rounded. So I'm just going to do that quickly now with a round function. So round all of that to 2 decimal places, and the same for this one. Round all of that to 2 decimal places. Doing it here means I don't have to transform the data anywhere else in my front end. If I get this thing where it's integer, it means that the average, I need to cast it as a decimal, so it knows it's allowed to do that rounding. So there we go. Much tidier numbers. I'll save that as my delivery card data. So now we can go back to our design tab and without much fuss, just add those things in. Now we want it to be filtered on month and day. So actually I'm going to delete the first 3 blocks because this final block is already filtering on month and year. So if I switch this over to be our delivery card data, and our first one can be, so deliveries this month, so total deliveries, we'll call that deliveries this month. We'll duplicate that. Our late deliveries, so count of late deliveries, and we'll duplicate that a 3rd time. It's going to be our percentage deliveries, so we'll do our percentage of late deliveries. And then finally, we'll have the average number of hours behind schedule. So our query will return a positive or a negative number depending on whether we're ahead or behind schedule. So if we do our title, So we just want the absolute time of our cards block average time difference. So if it's negative or positive, we'll just get it back as negative. But for the subtitle, we want to say behind or ahead of schedule, depending on whether or not it's positive or negative. So the easiest way, I think, to do that is to use a ternary operator. And so we'll return. And we'll check is the time difference. If it's greater than 0, so it's positive, then we are going to be ahead of schedule. I say greater than or equal to 0 in case it's exactly 0. So average hours ahead of schedule. But if it's negative, we'll say the average hours behind schedule. Let's see that. So we're ahead of schedule here. If this was a negative number, this would say we're behind schedule. That'll tell us how many hours is there. So there's our finished cards. We look at our deliveries data. We're going to make a pie chart out of the origins of our data. So how many deliveries are coming from each origin. So we'll create a new query, and this is going to be late deliveries by origin. Again, I'll copy and paste it. So I'm going to select the origin. I'm going to count the total deliveries. I'm going to count the late deliveries by checking whether or not the arrival date is, the difference between the arrival and the departure date is bigger than the total limit in hours. If it is, then we'll that row will give us a 1. If it's not, that row will give us nothing. So I'll count up late deliveries, and then we'll count up the total of late deliveries and divide that by the total. Gets us a decimal and times it by 100, which will get us a percentage. Again, I'm going to use the round function to turn that into 2 decimal places. We're getting all that data from the deliveries, and because we're using some aggregators, we want to group it. And for us, we want to group it by origin. So we're going to have one row for each of our regions or origins. So this is the first row, Pittsburgh, 2 deliveries, 1 was late, which accounts for 50% of our deliveries. In our schema, we probably want to cast things to our numbers as numbers. It just might help things later on. And in our preview, we can see the rest of the data that's going to be there. Let's save that, go back to our front end, select our chart. This is going to be our late deliveries by origin. We'll then change the label column to be origin, and we will change the data column to be a count of late deliveries. You see Boston's getting things that are really late. So this is absolute. You could change it to percentage if you wanted to see, actually it's not as bad as it looks. It's just that Boston has more deliveries going on. So percentage versus absolute there as well. So maybe for our pie chart, we'll do the count of late deliveries. And in our bar chart, if we swap that over to be our late deliveries by origin, we can change the label to be origin and the data column to be the percentage late. So the final chart for this dashboard is going to be our line chart at the bottom. And for this, we want to show the number of deliveries and late deliveries for each day in the month, just so we can see them going on. So we'll need to do something similar with the with statement. So go to Postgres, queries, create new query. I'll copy and paste this again. So we are generating a table called all dates, where it's a series of dates from the first of this month to the current date in an interval of 1 day. So we're going to have a value for each day of this month, which we're calling all dates. We're then selecting the date from that as the departure date. We're counting however many we have that match that date time to be total deliveries. We're then extracting the number of late deliveries. So we can sort of work that out. We've got this count case going on. We have to handle a divide by 0 problem when we have our no deliveries in a given day. So we want to avoid divide by 0. So that's what's going on there. And then we are working on our average. Let's run that query. Again, percentage late, we want to do a bit of a rounding thing going on there, which starts here. So if I round all of that, to 2 decimal places, looks a bit better. And we will call this deliveries by day. So go to our design, go to our last chart, and change the data over. So the data is going to be our deliveries by day. What do we want to show? Our label column is still going to be the departure date. Our data column this time is two things, our total deliveries and our count of late deliveries. So now we can see on each day, here we had 1 late and 1 total, so all of them were late there. Here we had 3 total and 1 late. So yeah, so we've got some idea of some visualization of the data that's going on there. So the final thing we might want to tidy up is our links. So at the top of our page, we can add our vehicles and our deliveries. It's going to link to our delivery screen. We'll save that. And now we're ready to share this with our team. They can track our deliveries and all the things that are going on. We maybe should be concerned about Boston, but looking at the percentages, maybe not. But 50% late deliveries is pretty bad across the board, so we maybe want to short that out. And our vehicles then, we can see, hey, we've got our average age of 2.53 years. We're spending a lot of money on fuel this month so far, but we can sort of see what's going on. Hopefully this has given you some ideas for the kinds of dashboards you might want to build for your context. Obviously that will differ. You'll have different data and different metrics you'll want to show, but the building blocks we've explored today will help you be able to make decisions and turn your data into action. Let us know below if you found this useful, and I'll see you here again soon. Thanks. Bye.